Good morning, everyone. It's really a very, very important privilege for me to speak to you straight 12 years in a row. And today, I really also like to do my best to share a subject that is also very dear to me because I've been studying this thing quietly on and off at least for, let's say, since 2003 after that hockey stick story. That I kind of got a bit bored with that silliness in Michael Mann's hockey stick, so I decided to study a little bit on the effects of mercury and methylmercury on human health. I start with this slide because, by the way, there is no pre-arrangement within me and Jane that I'm so happy that Jane reminded everyone on our very distinguished and colleagues and friend, Sally Balunas, who's also person that I worked very closely with for many, many years. And it just so happened that a few weeks ago, I happened to saw this advertisement used by NASA education folks. And then on Friday, I hope some of you recognize, this is our friend Sally Balunas. And I pointed that out to her. And we're glad that the legacy of trying to educate younger children and perhaps girls specifically to motivate them to get into science is probably a good thing. Let me start then with my brief remark here. Today, as you can see, I'm trying to talk about a subject that is a bit out of my range of expertise, but I've explained to you I have some strong interest in such an issue because it's really essentially that it's been very highly politicized. I mean, you perhaps may have heard about the rules from the U.S. Environmental Protection Agency on trying to create these rules to not allow anyone from emitting any more mercury, as if this mercury just simply only came from industrial sources and so on and so forth, without a lot of those caveat and details about how basically nature essentially dominate this aspect of mercury recycling and actually the bio-geochemical chain of how mercury come about into our fish and essentially to the point where we're eating them. And I do have to declare my very proud title of being an independent scientist because perhaps soon I will also be out of a job, so I better be a really independent scientist who sort of reject a lot of this bad aspect of taking government funding because it's very highly corruptive forces, as you all can imagine. And I'm here to speak strictly on my own and do not reflect anyone or any institution. And I would make the disclaimer, especially my friend Juan Ramirez or even the next speaker, Professor Matt Briggs, because I might embarrass them. I start with this prelude. This is what I call the twilight zone time on all my research on mercury science. This is really very strange stuff, but I thought it's worth reminding because this is, after all, something related to medicine. There is indeed a rumors going out there saying that all these efforts of saying that the so-called biological toxic form of mercury called the methylmercury, the chemical formula is CH3Hg, saying that all this stuff about mercury in fish does not harm people, as some of us would like to say, but we have empirical and strong reason and explanation to that. It's because of Saddam Hussein. And that comes from Dr. Jane Hightower from San Francisco. This is an internal medicine doctor and practice in California Pacific Medical Center. Let's see what she said. So she essentially decided that she has to write this book called Mercury, Money, Politics, and Poison. And then from the book promo, she's trying to say why the US FDA based the recommendation on safe mercury consumption is supplied by Saddam Hussein's extremist group. Here's the reason. On those various pages that I have the pain of going through is essentially trying to tie the plausible connection of Saddam Hussein with this three famous incidents of true mercury poisoning. This is a very unfortunate situation because, as you know, mercury, not only that it wanted to end up in fish, but then it can also have a lot of practical uses, industrial uses. One of the well-known uses in the past is basically as a fungicide to try to protect all those grains from being rotted so that you can actually use it to store it for a long time, and then essentially we'll be able to even use it for planting and agriculture. And there are some indeed very unfortunate incidents in Iraq of mercury poisoning, because instead of for those folks to use this grain to try to plant and then generate more grains, they actually use it to bake the bread and then eat it themselves and ultimately get poisoned. And then there are many also unfortunate situations, because a lot of these fungicides, these grains are being color-coded in red color, that these folks go and wash it so that they thought they ultimately clean those toxins up, and then they go and bake those bread. Worse yet, those guys are so smart in the sense that they even feed it to the grain to chickens and all that. They tested all those things, and then the chickens appear to be fine for weeks. But because of the nature or toxicity of how mercury really works, that eventually we know that those chicken would also eventually die, but they did those tests and then they didn't see any effect, so they started to bake those bread and feed it to their family. So apparently there are some relationship of Saddam Hussein with this Ministry of Agriculture in the past, in the 60s, in the 50s, and the 70s. And then saying all these things that possibly Saddam Hussein is purposefully trying to poison all the Iraqis and perhaps create this modern phenomenon of denial on methylmercury in fish, not causing children to go crazy or lose all their IQs. Well, the link is essentially because of this well-known paper that is published in 1973, because the first author of the paper, Dr. Farhan Bakir, is a personal physician for Saddam Hussein. But he really fled Iraq in 1981, and he's now living in Abu Dhabi. And my only one question in terms of that proposition is that what is the likelihood of Saddam Hussein of Tikri knew about the differences between ethyl versus methylmercury without internet? Because the true story is that those fungicides were coated with some form of ethyl mercury, especially the 56 and 1960 outbreak. Even in the 72 outbreaks, it was said to be coated by ethyl mercury. But until the previous paper, Dr. Tom Clarkson of University of Rochester and their group actually went to Iraq and then take those samples and then really chemically analyze it and found out that it is not ethyl mercury, but it is methylmercury. I mean, it takes that kind of scientific evidence and work. So there's just no chance that Saddam Hussein, if you know any difference between how ethyl mercury work and how methylmercury work in terms of poisoning people. But I want to start with something more happy. As you all can see, this is our great President Dwight Eisenhower and his brothers, 4 brothers, fishing for muskie and northern pike in Pine Lake, Wisconsin in 1946. I have about 3 points to make in showing you this picture. The first point is to remind you that because of the nature of how mercury works and how it transformed and turned into methylmercury and ended up in fish, which I'll explain in a minute, but I want to assure you that if you go to that lake and catch it today, 2012, I am quite sure that there will be no difference, major difference in terms of the methylmercury in the fish content, in the fish tissue, in the sense that it will be higher now today because we, or folks in Wisconsin, the power plant in Wisconsin has emitted some of this mercury and it's landed on the lakes, and somehow this mercury will get increased. The second point is that I want to assure you that even if President Eisenhower's mother has eaten those fish, or he himself has eaten those fish, he's fine. He's not mentally ill or something, right? I mean, in terms of that, we have a proof, actually, the real test. I mean, he ate those fish and then he didn't go crazy. It's fine. He's not affected by that. More importantly, I truly want to explain to you the reason why that I think there is no way in the world, if you study all the available evidence carefully, and as much as I'd like to say that I have studied it for almost 10 years now, I want you to be assured that this, in terms of the chance, the likelihood of children when they eat those fish, as you know, is a nutritious food. Even though you have this trace amount of methylmercury, and indeed methylmercury is this very, very, very potent neurotoxin, but the beneficial effects of these things way overwhelm any tiny negative effects from methylmercury. So there will be no chance of anyone being harmed by this. I mean, I think we have more than enough historical evidence to try to support these things. But I guess the main point that the philosophical aspect of my talk today will be trying to point to this very well-known speech by President Eisenhower, his farewell speech of his administration that was given in 1961. The quote you can read for yourself, but then I think that his caution is really, really timely and urgent. In fact, we already fully realize it today, in my humble opinion. It is that science, instead of being the very, very useful and powerful tool or that given tool to enhance human, I guess, civilization and intellectual curiosity, so on and so forth, has essentially now turned into a very convenient weapon for actually more control, or worse, for bureaucracy, through the strategy of basically fear-mongering, for scaring people, okay? For narrowing, talking about mercury being a neurotoxin, so therefore we must 100% get rid of all the mercury. There shall be no mercury everywhere in the world, zero mercury. That's basically what these folks are driving at. And then science is somewhat being used to help this proposition. And indeed, of course, the prospect of domination by our nation scholar by federal employment, project allocation, and the power of money is ever present and is gravely to be regarded. So I think that throughout my talk, I will point out some aspect of why this particular quote is this speech is so relevant and timely. So my job here is not too difficult today. It's trying to discuss with you about this myth of killer Methylmercury into 6 easy pieces. Obviously, it's not so easy, but of course, I like the word easy pieces from Richard Feynman. My idea here today is basically trying to tell you that if you start from beginning to the finish line about what EPA is trying to actually tell us, first, they say, mercury, methylmercury, they are neurotoxin. If the power plant emit more of it, it will end up on the lake and soil and the oceans and everywhere. It will end up being transformed into methylmercury, and then ended up in the fish through the food chain, through the process called bioaccumulation and biomethylization, and then ended up in the fish, and then some of us who are very good fishermen, I hope some of you are, we go catch those fish and then we eat it, and then we fed it to our kids, and then our wives perhaps get pregnant, and then our children, when they grow up, they're gonna get mentally defects, not able to pay attention in school, or lost their IQ, or crazy. And then ultimately, the EPA say if you cut, all you need to do is cut this emission from coal-fired power plant, for example, operated by my friend's company, Juan Ramirez, in Florida and everywhere in America. And then you will essentially have all these problems that they propose go away. And then I want to go through each of these individual factors that I selected, about 6 of them, for convenience. There are obviously more of them. This change of reasoning. And then to ask that, what is the probability for this being correct? Even though we have proposition 0, P0, that is absolute uncertainty about mercury or methylmercury being a neurotoxin. So let's go and study all these 6 factors. But the first one, I'll start with this proposition P0, which is to say, yeah, mercury is a highly toxic pollutant. I say for the convenience, we don't want to argue endlessly with this, but I have researched this topic deep enough to know that this statement P0 equal to 1 is definitely not true. Here's the reason. Well, we're dealing with something called methylmercury, right? I have this rock band. This is the metal that is formed in marine environment. By the way, I do like to say that I come from MIT, but it's one of those famous MIT that is not Professor Dick Lindson's home institution, but it's one of those called Metal Institute of Technology. First, I want to at least give a basic tutorial, this is through my own learning, about why methylmercury is such a powerful neurotoxin. Essentially, this methylmercury, the CH3Hg plus symbol, is essentially able to combine with this well-known L-cysteine amino acid, and then kind of fake the system. So the complex becomes this particular middle methylmercury complex that looks very, very similar to the large neutral amino acid called methionine. Okay? It's really essentially different, similar, except for that chain that I was pointing out. So this is why our body tissue are being fooled by this particular nature tricks, right? That you are able to essentially have methylmercury very, very quickly. One is in our bloodstream, it will spread all over all the tissue within 30 hours. And then our body metabolism have a very slow way of getting rid of this methylmercury, turning it into inorganic form. In the half-life, of course, some individual there are some certain genetic component, but it's more or less average amount, get rid of our body, half-life of this methylmercury in our blood is roughly 45 to 70 days. So it takes a long time, but indeed, if you stop eating this, your body will be able to work in some sense. Of course, the full mechanistic explanation is not understand. As of today, we don't even understand why methylmercury always wanted to end up in our hair tissue, and which is the most concentrated place, right? It's 250 times more concentrated in hair than in blood. So this is why mercury is such a powerful neurotoxin. In fact, the dimethyl form is even, million times more toxic than that. But the argument against this zero mercury proposition is actually based on some empirical evidence like this. I think this audience in DDP no need introduction about this famous, well-known dose-response relationship called the homeotic dose-response relationship, homeosis. It works in radiation of all wavelength, more or less, and many more phenomena. But in terms of mercury, we also do know that somehow there is this homeotic dose-response relationship, in the sense that you have low dose is stimulation and then high dose is inhibition, so it's bad. So in that sense, for this particular experiment that's done by injecting methylmercury into eggs of this mallard, that, by the way, they've done the experiment so carefully that you not only directly injected into the eggs itself, the methylmercury, which is very, very potent, so the scale looks very small, it's 0.05 ppm, but then you've done the natural experiment in the sense that you feed those methylmercury to the mother, and then the eggs was born, and then you do that measurement. That 0.05 scale there is roughly 0.8 ppm of methylmercury, which means that the direct exposure of this thing to methylmercury is a whole lot more toxic than actually through the natural thing, which natural ingestion processes. Probably our body is able to handle some of those, just like the way what I say that when we eat fish, we probably will not be poisoned too much by such a process rather than taking methylmercury directly. Then we have this very famous physician, Paracelsus. But the reason why I put out this quote is to remind us that indeed, it is the dosage that makes a poison. But it also has a small historical coincidental link to mercury itself, because mercury, as you know, is used for fungicide, but is well known also to be used early on when people realized that for skin infection, for example, this is actually the first thing that where Paracelsus noticed that this mercury has that kind of power, but too much mercury killed those patients. So probably dose make a poison is very, very, very relevant. So let's start with the first test, the first proposition. And this is basically the test of the simple question is first, has never seen methylmercury in fish before, I guess, before US power plant or industrial sources use of mercury, like caustic soda power plant and all those things, that before this human effect come around, that there will be, I guess, no mercury. It's a nature doesn't do this, doesn't recycle mercury from land, soils, and ocean to the atmosphere and then come down again, back and forth, right? For this, I'm going to be very, very generous. I say we're going to assume that this proposition to be true, to be only 10% being right. Okay, it's a very conservative one. In fact, I think it's near zero. In fact, one of these factors, if it's near zero, then the whole change of argument just not work anymore in terms for the EPA sense. So let's start with this first estimate. So how much mercury do we emit, or how do we quantify all this? The usual story is basically, in some sense, I'm trying to point to you some of the misinformation out in the literature. The most important one that I want to highlight here is basically how much does the volcano emit? Because what it says is that human emit, the industrial sources, human sources, anthropogenic sources, emit roughly about 2,200 tons per year. Okay? US, as we know, emit only about 100, and then US power plant itself is about 40 to 45. And then just by forest fire itself is about 850 tons. Forest fire, you can say that it's man-made or not man-made, but it's a very huge amount because there's a lot of mercury sitting around in soil and basically in cellulose of trees and all this. So therefore, once you have all this forest fire, which happen every single day on planet Earth, and you do emit a lot of this mercury to the air. But what I wanted to point out is that if you ask and look into EPA literature, who trying to tell us that man-made mercury sources is important, they're obviously trying to underestimate what the mercury emission from volcano is, because I guess EPA is not trying to regulate volcano yet. Because there's a well-known study, the reason why I'm very bothered by this is that I specifically want to highlight here is that it is well known from the best possible study. In science, you always go for the best possible empirical evidence. It's known that volcano emit, the time mean, is roughly 700 tons per year. And in some of those very active days and active years, you can get up to 4,000 tons a year. They obviously was not trying to promote that. And EPA essentially tell you that it's going to be only about 100 tons. And they select purposefully, in my opinion, very low number, and then based on some kind of published literature, that's where science is becoming a tool to this policy nonsense. An ocean naturally emit about 2,000. The estimate is very, very difficult to estimate. It can be 2 to 10,000. That is the kind of numbers that is not well known. And here's just one example of why EPA, including the former EPA chief, Mike Leavitt, during Bush administration, was insisting that mercury, citing that sources, that has to emit about 100 tons, while ignoring a well-known study by David Powell and Mata, which is the student, which is from, at that time they were from University of Oxford, and then they now move on to, they were at University of Cambridge, and then they move on to Oxford because Oxford pay them better, perhaps. But these are volcanologists. These are volcanologists who make serious attempt to try to sample all over the world's volcanoes and try to estimate how best to estimate. Essentially, it's trying to estimate mercury emission of this through sulfur, of course, because there's this strong relationship between sulfur and mercury. But they come up with a number of 700 tons. And why would, if you really follow the best science, obviously you will pick this number. Actually, I think there's no question that you should take this number rather than hundreds, okay? But if you want, speaking of volcano, I just want to remind how powerful nature is. This is one of the best examples. This is a paper that just published recently by a geologist and Canadian group. It's talking about this very huge event that emit about 3.8 billion tons of mercury. This has happened during the latest Permian era of 250 million years ago. You can say that's a long time ago, but that's where all the mercury in all the land and soil perhaps came from. If you turn that number into something that we can understand, okay, in the context of, let's say, current man-made amount of mercury emission, roughly 2,000 tons, that is 3 to 4 times larger. This amount, 3.8, is basically 3 to 4 times larger than the current man-made mercury emission, not for every year, but lasting for straight 500,000 years. So that tells you that the volcano sources of mercury is really very, very significant and cannot be ignored or cannot be just swept away by EPA ruling. And then from my own independent investigation, I have come up with at least 4 or more different categories of amount of what I call natural component of the mercury emission sources that hasn't been accounted yet by EPA. And these are just some examples. The blue chart is showing you the low estimate, and then the red bar is showing you the high estimate for 4 different sources. From forest, as I told you, forest itself, not through fire yet, vegetation, direct emission, from soil, let's say. And then from soil in region, let's say, that is very, that is full of mercury, through mercury mining processes and all that, right? These are huge amount. This is 1,500 tons. Right? Compared to, let's say, the total estimate man-made sources of 2,000, it cannot be ignored. But this number has not yet been included in EPA's mercury budget. And then, speaking of politics, Art Robinson, from the state of Harry Reid, as you can see, Nevada, I don't think you can do anything at all to control the mercury emission. Because from the soil and all these areas in Nevada, it emits about 10.4 tons per year. That is a lot, huge amount of it. And this kind of number has not been yet accounted by anyone or EPA. But at least the estimate has been done that there's a huge amount of this natural emission of mercury from our soil. And then I have a very important test. Because I want to tell you now, let's say this is the best estimate of how much man emission of mercury is. Here I take this recent study that says that in 1996, from all these different sources, we emit about 2,128. And then by 2006, 10 years later, we already increased the emission a little bit more. So by 2,500. Remember, a few hundred tons is really a lot of mercury in that sense. Okay, I just cut off all this future projection stuff based on IPCC scenario, which is pure nonsense. So we're just going to ignore that for now. But I want to ask you, if you really want to entertain the proposition that mercury can only be coming from man-made anthropogenic sources, then I think this is a very good empirical test. This is not a setup. This is just the way I think and the way I found out. So you have this increase over from 1996 to 2006. If man-made sources is really important, if we do have the kind of measurement that we have, that I think we have, which is you go out sample the mercury content in the air itself, which is very, very minute component. This is part per trillion kind of numbers. If you can measure that over this time period and you have data for that, if man-made sources is important, guess what happened? You should be able to see somewhat increasing trend of the, I guess, mercury concentration in the air, right? Because after all, he has to go through the air and then come down again. Here's the empirical test. Here's the data. It turns out that thanks to the Irish EPA, they actually have a monitoring program as Mace Head on Northern Hemisphere. So those are the blue dot. Sample from basically 95 until 2009 or 2010, based on this new paper that just been published by Franz Slammer Group in Germany. And then Southern Hemisphere, we also have ship crews and then 2 local stations where you sample this air and then you measure how much mercury content is. Okay, so this is very systematic, kind of accurate measurements that you do over time. I guess the proposition of mercury, man-made sources being dominant, cannot be supported. Because atmospheric mercury data actually showing you that they've been decreasing ever so slightly. And I don't even dare to talk statistics in front of Professor Matt Briggs here. But the point is that it's not going up, right? So therefore, what does this tell you? It's a very simple conclusion. That man-made sources is perhaps not dominating the amount of mercury that is staying in the air. That's all. And then there are many more details you can try to talk about, but I think this just doesn't tell you that those idea about man-made sources being important doesn't hold water. There's no need more argument because they're trying to say that, yeah, volcano is not important. And I want to remind everyone, mercury is really everywhere. This is one of the fun things that actually in science, it's recently been found that in some southern cold spot of a South Pole region of a moon, that you actually have about 2,000 ppm by mass in moon soil, mercury. And this is a very nice experiment they did in one of those L-cross experiments, thanks to our taxpayer money, but they were able to do this experiment by basically dropping the last stage of the rocket Centaur and then drop it on the southern area of the moon in one particular crater, and then kick up all the dust and then to the high, again, this wavelength is in high, far ultraviolet, so they're measuring that and found a component of Hg there, marked by the wavelength around there, between 180 to 190 nanometers. So you're able to detect this particular surprising effects of having so much mercury concentration in the moon soil itself. And then as a person from astronomy and astrophysics, these are also well-known kind of stars. This is one of those chemically peculiar stars that what I'm trying to show you that at least in 2007, this group of scientists were able to find actually quote-unquote weather that is essentially caused by fluctuation of this mercury, highly concentrated mercury cloud in the atmosphere of the star. It's a really amazing phenomenon because they show how this pattern are actually changing over a short time period. So essentially seeing weather that is induced by this mercury cloud in the system. And if you want to know how much mercury you have on this kind of atmosphere, it's actually the scale there, the highest scale, the blue scale, 6.4 on the log unit. It's basically 2.5 times 10 to the 6, or 2.5 million times bigger than what the solar abundance is. So this kind of stars is really telling you that in some system, this is a hot star, slightly hotter than Earth, the 10,000 degree, the main star. So, but you do have quite a lot of a Mercury. It's well known that it's everywhere. And then this is my own little kind of accidental finding that I find it very, very curious, so I want to share with my best audience around. These are the group that really invited me to speak for 12 years. And this is basically, we finally do have the first evidence published around 2009 or so, that we do indeed now have, through study of this carbonaceous chondrite, that you are able to determine how much mercury content you really have in terms of the material that really started the whole solar system 4.55 billion years ago. That number turns out to be about 0.35 ppm. And I do want to point out the coincidence. If you study coal or even black shale, the number can be up to 0.2 something, okay, in terms of mercury concentration. And then guess what? In albacore tuna, it's roughly 0.35. That's FDA numbers. But I think if you can do a lot of sampling, you will roughly come out to that number. So central limit theorem, I guess, perhaps some kind of averaging. But this is one of the very interesting coincidences, trying to point out that mercury is everywhere. And the reason why I mention this is because for you as an audience is that the reason why I kind of stumble into this thing is that, as you know, there is this ancient question, where does life come from? How do we build this immune system, for example? So you think about it in real sense that studying of mercury is helpful in that sense because perhaps the evolutionary history of life system on planet Earth is related to amount of oxygen that we have. Because the same protein and all this anti-oxygen molecule that actually protect us against oxygen in our body has perhaps it's the same one that is protect us against mercury. So there may be some interesting relationship for further study, obviously. Then there is this new puzzle from planet Mercury. This is the result that just came out. We find some Mickey Mouse sitting around there. Okay, let's move on to proposition number 2, which is really the idea that saying that this mercury, because, by the way, power plant doesn't emit methylmercury. You cannot make methylmercury so easily, okay? It requires biology and chemistry to do that. Power plant emits something in a more, what we call just a regular mercury, the raw mercury, elemental form, Hg, okay? Or Hg plus, or ionic form. You emit this and essentially has to go through the change of, bio-geochemical cycling, biomethylation, accumulation processes to end up in fish. And this is why I say that the amount of methylmercury is not dependent on mercury available or even power plant available. It doesn't matter, but the whole process is controlled by something what I call uncontrollable geological, environmental, and ecological variable. So we want to entertain that for this proposition, EPA proposition to be true, we give it a likelihood of 10% being correct, which is very generous if I hope to show you the evidence. Here's one of the best, my favorite example. You go to San Francisco Bay, specifically San Pablo Bay area. You go sample the water, the amount of mercury in there. So the blue chart in 4 locations. The blue bar here showing you the total mercury sample amount in the sediment actually here. On the left scale, okay, 0.0 to 0.4. You measure in that 4 region because they are more or less same locality. Look, the total mercury amount is more or less the same within the area of uncertainties. But if you go sample now the amount of methylmercury in this sediment, guess what happened? In the open water area, 1, 2, and 3, the amount of methylmercury is very, very low. But in salt marsh, right, where you have a lot of this really good biology or chemistry around, look, the amount of methylmercury is very, very high. Okay, that just simply already tell you that the amount of methylmercury being made or transformed into methylmercury kind of have no relationship with how much total mercury you have. Not in a strong way. Then you have another puzzle like this. This is what they call the methylmercury accumulation paradox. This is not my word. This is a word coined by some of those scientists who still try to get government grant after seeing this for sure. That what is plotted here is basically the amount of mercury in the form of methylmercury as a percentage of total mercury available, right? So total mercury is methylmercury plus all these other form. So from about 0.01% to 100%, plotted as a function of total mercury amount in the water column. This is sampling over quite a lot of areas, lakes, rivers, wetland, and estuary, what have you. But guess what the tendency of the data tells you? It tells you that if you have more and more mercury in the water, that you tend to have less percentage of that being turned into methylmercury, this biological toxic form. This is a very curious phenomenon, but it's also somewhat explained actually, because supposedly they study in all this system that when you have more methylmercury, you just simply increases the amount of those methylmercury resistant bacteria. Then they are able to break down this methylmercury. Remember, just like the ozone issue, you not only destroy ozone, you also make ozone. Same thing with methylmercury. People are just trying to tell you how you have methylmercury, but they don't tell you that you can demethylate the cell also. It's a fast process. Okay? So don't get fooled easily by those things. And this is just simply my list of evidence, just my brief research. Actually, I stopped collecting. There's just a lot of data telling you about, in all these individual factors, about factors that is related to how mercury from elemental form transform into methylmercury. And the list on and on what the visible light, how much UV, leaf litter input. Like some places, if you treat the experiment with sulfate, you will see how the things are being controlled by sulfate. Algae bloom, so on and so forth. The final study is really, really interesting. This is a study from Sweden. They are studying actually the mercury level in this fish perch. And they study 48 environmental variables and see which one is dominating, which one is controlling the amount of methylmercury in those fish. With these 48 variables, they can only explain less than 50% of the total, the methylmercury in the system. They're still unable to identify which are the one that is important because there's just so many factors. Land use, how much previous land use, history, catchment area, lake characteristic, the water chemistry, and so on. So it is a very complex chemical, biological control of this thing that has nothing to do with how much mercury you already have in the system. Remember, the mercury has been sitting there. And now I have this very contemporary example from from Florida Department of Environmental Protection Agency. This is based on the thing that came out in May 24, 2012. My friend Juan Ramirez can tell you this story a lot better than I can. But what I want to tell you that at least based on these sets of data, that if you measure the amount of mercury in the fish tissue versus the total mercury in the water in all the lakes and rivers that you sample in Florida, please someone trying to tell me that if you increase more of this mercury in the water, which means that it has to come from industrial source level, and then you will have something to do with the fish mercury tissue amount. I don't see any relationship. By the way, as is very typical of the government bureaucracy, Art Robinson, this thing has been deleted, of course. This graph, when I first pointed this out, I believe that me and Juan are the first two, because I guess nobody cares, but we're the ones that's so busybody, have to write newspaper story and talk about this. After we point this out, the second draft that issued in July 3rd, right? July 3rd or July 5th, already get rid of this picture because they are so scared of this. But thank God that we have a way to recover this whole thing. I can plot this versus methylmercury too. There's no relationship. So that's really dangerous. And when they published this in May 24, guess what? They even have a code like this. They say no relationship is observed in terms of the fish mercury tissue versus the amount of mercury in the water. And then they use these heavy statistics that Matt Brick can explain. No pattern of a linear regression nor an assessment by graph theory is observed. Okay? This is undeniable that's what the data say. And guess what this statement is now? Is of course deleted. They hope that history can be erased within a few months, Terrible. Now proposition number 3. This is actually the EPA's kind of proposition say that the human mercury level in the human and environment will always low, meaning that let's say the fish caught by President Dwight Eisenhower and his brothers will let's say very low, like 0.1, 0.005, and then today is about 1 or 2 or actually 0.5. But this proposition is really not true. And I also very conservatively give that the statement for being right is about 10%. Okay? Let's have a look at the data. First, let's remind ourselves. Like I say, mercury is everywhere. This is mercury detection. It's very, very low concentration. Remember that, okay? Picogram per gram. Over last 650,000 years from the famous ice core in Antarctica, it's basically the point that the blue curved line connected with the point 650,000 years ago and then until today. That you measure the fluctuation of all this mercury concentration in the ice, trapped in the ice. And you can see it jumped by really, really huge factors. And it probably related to basically during very cold period, you have more dust delivery that attached a lot of this mercury and then ended up there. So therefore, you have higher concentration of mercury. And the dust is actually shown by the shaded orange areas. And now another test, because that's just something in the eyes, but what about human? Here is a very interesting thing that is being done by the state of Alaska, in the sense that invoking that we are the state of Alaska. We don't see a problem in mercury in fish. We don't see about feeding our children and women with fish that caught in our water, okay? Rather than letting the federal government come and tell us that this is not right, you're killing your children, you're making your children stupid. But the point is, they have instituted a program of monitoring basically how much mercury is in the hair of those pregnant women. So this survey has gone on for almost July 2002 until 2010, okay? What they did is that then, from all this large sample of observation, they actually determined a median value of hair mercury of about 0.44 ppm. I'll put in context in a minute. But if you compare that 0.44 ppm to basically what they call the Aleutian mummies that's been radiocarbon dated to be 550 years old, if you measure the methylmercury, by the way, that was total mercury, and they measure this in methylmercury, the amount in those Aleutian adults is 1.2 ppm. By the way, there are 4 infants, 1.44 ppm, okay? Remember, 550 years ago, you don't have power plant, you don't have SUV, you don't have all of this. In total mercury, the value that they measure for those 4 adults is about 5.8 ppm, as I show in the line there. I mean, there's practically nobody in Alaska today have that high level of mercury. This is probably related to a lot of fish that they eat during those times because they have nothing else. And then people actually attacking me for showing this result. They say, how do you know that those Aleutian mummies are not crazy? But then I say, well, excuse me, if you really agree with EPA, then you know what? The fish mercury got to be really, really low back then. You know what? They don't really have to eat 1 pound of mercury per day, every day for 70 years, like EPA say. You have to eat 10 pounds of it to get that much of exposure. So I think they will die from really too much fish, actually, rather than being poisoned by mercury. So the chance is really, really very small, in my view. Then proposition number 4. In terms of the evidence of how bad methylmercury is, and this is really profoundly crazy, these things I want to show you. The EPA, instead of picking the best experimental answer, best understanding to date, which shows that really, really there's no strong evidence about how when the mother ate those fish with trace amount of methylmercury, and then when the baby was born, the baby would perform poorly in school and so on and so forth. I want to contrast 2 studies. The first study that EPA chose naturally is from Faroe Island, North Atlantic. Another study is basically from Seychelles Islands in the Indian Ocean. And the reason why EPA don't pick the Seychelles Island study is really, really amazing. And I want to correct the myth. They've been saying, no, EPA has included everything. They have taken into account Seychelles Islands. But please, somebody, go read the NRC report in 2000. You will see a line that say, the reason why we don't consider Seychelles Island because they didn't find the effect. Period. And there's this rumor going out there that they have so nice, they've been really very inclusive, they include everything. No, they did not, because the result didn't find the answer they want. And they picked this Faroe Island. If those Faroe Island people are eating fish, then I'm much more happy. But the main way of how those people were basically exposed to this high level of methylmercury is because they're not eating fish. They're eating pilot whales. The pilot whale has been measured in terms of the chemical things in the pilot whale. It's not only methylmercury that they're eating, actually. They're exposed to a range of chemicals, DDT, what have you. So many things, PCBs and PBDE and ABC, all have you. It's all there. So for this, the proposition for the EPA thing being correct, again, very conservatively, let's be nice to them once in a while. It's 10%. This is the data, by the way. Please raise your hand. Some of you may have seen that I gave a talk on mercury long ago, 10 years ago maybe, that I showed this data. How many of you have seen this? You heard so much about methylmercury killing babies or making babies stupid. How many have you seen the actual data, the best data available? Please raise your hand if you have seen it. Not many, huh? Oh, I'm very surprised. But anyway, this is the best data, by the way. This is the test. This is the test done at 7 years old, when the children reach 7 years old, and we do measure the amount of mercury in the cord where the baby, they give birth to the baby, they analyze those cord blood mercury level. So it's going from 0.5 to about 512, right? Microgram per liter. That's in roughly units of ppb, part per billion. And then this test is a famous test called Q Boston naming test, and it's different from non-Q one, of course. Okay? So they were given Q, okay? And good score is up, blue. Worst score is going down. So please, somebody tell me. I really want to understand this thing. Can you guys see that if you increase the level of exposure of methylmercury, that do you see any bad effects of this Boston naming test? Do you see anything bending down? You cannot, right? Okay, EPA will help you. EPA put in this statistical regression curve. This is the one that I want to get Matt Briggs excited about, and then let's fight this thing, because they haven't released this data. We requested it many times. They don't release this data. And it's paid by the US NIH, some of it. And the Danish government pay a lot of it too. But science should be available. The data should be available to everyone. So EPA help you, okay? EPA help you. Please, we're trying to show the graph. So this is the level. But really what is amazing is that they're telling you that this thing is curving down eventually. And guess what happened? If you were to say that the data is curving down, I will put it at the blue line, okay? Roughly about 58 or so, right? But EPA say no, that is too high. We want to be very, very super safe. Guess what happened? They put at 5.8 ppb. They say we got to have safety factors, so they actually put the data there. This is what President Eisenhower say. You sit in your office all day, you think you can make rules and regulate people's life. You forget to look at the data. The 5.8 is really ridiculous. It says that if you are above 5.8, your kid will be crazy. Less than 5.8, your kid will not be crazy, based on that data. It doesn't make sense, the 5.8. You don't have to say anymore. It's crazy. Worse yet, what is science about? It's about replication, whether you can repeat the experiment. This is a very special chart built by Professor Gary Myers and Tom Clarkson at the University of Rochester School of Medicine. They did the same Boston naming test. Okay, for Seychelles Island students, they measure the prenatal mercury exposure through hair, because hair is much more accurate than blood, cord blood. And they were eventually couldn't repeat this argument. They couldn't repeat these things. This is the kind of graph that actually EPA never ever want you to see. In fact, they didn't make even this plot until a lot of urging. They only put it in a statistical table, in one of the tables cited there, okay? Because they were being attacked also for not showing things like this, okay? They're being attacked for, please don't show this because it's too dangerous. So when people say the mercury is rising, I think you just remember they're not talking about the temperature. They're not even talking about the fish. They're really talking about whale meat. I hope your mother don't eat too much pilot whale. And this is now a context. We, US, we have measured also the amount of mercury in cord blood, in blood of women and children. It's 1 ppb and 0.3 for children. And then these are a range of other values. And then look at the children in Minamata. The one that famous Japanese poisoning case, because the industrial processing dumped directly methylmercury into the ocean and coastal area, where it reached 216 level ppb, very high. Okay? EPA say that 5.8 you enough to kill yourself. So now I want to tell you what happened, because we have this. The CDC have the National Health and Nutrition Examination Survey, NHINS. The data is available for women, 1999 to 2008, they do it bi-yearly. So this period is basically the mean level is about 1 ppb all the way to present. Nobody see any changes, do we? And then now I want to put in context, because even if you don't worry about the quote-unquote average American, but you do worry about the people who eat a lot of fish, for example. So take the 95 percentile folks. Over this time period, you can see the first paper, by the way, the study that always says that a lot of women in America are being poisoned by eating fish is basically based on that data. And then the new data, they never talk about it anymore. Okay? That you're kind of below this thing now. I'm not arguing that it's decreasing, really. I'm just trying to tell you that, at least now we have a lot of data, new data, showing you that actually it's not above the EPA RFD, which is already crazy. It should be more than 5.8. It has to be at least 60 or 100, okay? And this is the kind of thing that they're trying to play politics. They say we're poisoning our children, including us, who deny these facts of methylmercury. And I say, why you talk about hypothetical children, hypothetical pregnancy? The US NHANES also produce this data for children aged 1 to 5. Look at the level. You take the 95 percentile, folks. Okay? It's way, way below even the EPA extreme level already. So now, another puzzle. Because I dig very deep into the reason why they can do this study. Apparently, Institutional Review Board of the National Center for Health Statistics in CDC issued this criteria. You tell those patients or those people who are being monitored that they are in danger only if your total hair mercury is above 15 ppm or total blood mercury 200 ppb. EPA is saying 5.8 or 6. So I'm asking, is EPA the health expert or our nation health expert, National Institute of Health or CDC the health expert? It's a very puzzling thing. One more empirical test. If you want to say that EPA stuff is being reasonable, please consider this study published in 2004. Sample a lot of Japanese, 8,600 of them. You study this, you measure the hair mercury, you ask yourself, 87% of them have hair mercury exceeding the EPA's safe level. You have two conclusions. First, okay, is basically EPA is being extreme, okay? Or you have to conclude all Japanese are crazy, right? Because it's really large majority of them. Here's another study from Taji. This one, very small sample, 48 out of 50 of those, 96% of those people. This Taji is a well-known whaling community in southern Japan, where they eat a lot of whale. Their mercury level is to the roof. But you really have to consider whether those people are crazy or not. Go to Taji, I guess. It seems normal. I have a few report of somebody who went to live in Taji for several years and told me those people are okay. Quickly, factor 5. They ignore the very, very important. Here's one of the key reasons, biological reason, that why methylmercury as a neurotoxin is a neurotoxin. But then the problem is that when you study mercury or mercury issue, you really have to consider selenium in fish, okay? Which is really important. I'll show it in a sense. Mercury like to get bind with sulfur, okay, very strongly, cinnabar and all that. In fact, it's also the founder of bureaucracy because they use cinnabar for Chinese bureaucracy. You know, they write the red ink. This is the distinguished story about mercury. But then the binding of mercury to selenium is 1,000,000 times stronger chemically, okay? That's why you really have to consider what is the role of selenium in this study. So proposition and EPA ignore this completely. They never talk about selenium. They want to avoid this, even though they sponsor some research. This is one of the studies funded by EPA, published in 2009 by Nick Ralston and his group in North Dakota. What they did is that they went around basically quite a lot of sites, 12 western states, 137 sites. They measure not only mercury in the fish, they measure simultaneously the selenium ratio, the selenium. So you get the ratio. If selenium over mercury ratio is greater than 1, then you probably have more of the mercury get bind up with the selenium rather than being mercury alone. So here they found that 98% of those fish has actually more selenium than mercury content in it. Here's the data. Right? This is the place where they sample. And this is basically what it's saying. In most of the fish that they catch of all sizes, most of them have more selenium than mercury. And because of the strong binding nature of mercury, selenium to mercury, that perhaps the toxicity of the mercury by itself is reduced drastically. And Nick Ralston this is another one of my fun study that if you look at the chondrites ratio of selenium to mercury, Juan, this is the number you should remember. It's 58. Way, way, way higher. So it's already pre-made in that sense. And then people in health sciences, Nick Ralston and his fish community colleague, trying to be constructive, so they got a bunch of species from marlin to mahi, what have you. Mako shark is the only guy who have basically negative selenium health benefit value, meaning that if you eat that, you probably will get more poisoned by the mercury. And then ask about pilot whales in Faroe Island. It has a SBHV index of -70. Most of the fish are above this, which has a positive value. That just tells you that fish is nutritious. Omega-3, this kind of cheap protein, right? In fact, 2 billion people, if you ask Jane Luchenko of NOAA, 2 billion people of the world need this kind of food. They don't have food like us. And anyway, if you study 4 of the 16 species in Seychelles Islands, guess how much the HV, the selenium value they have? 400. on that index. So almost finished, sorry guys. But number 6. So I say that EPA, when they try to do this, and people say, oh, we're just trying to warn people, we're being nice, we're being extra cautious, all this kind of stuff, precautionary principle kind of nonsense. That, okay, what I say that now, the EPA is actually killing people because the fear, and this is the internet age that actually President Eisenhower is not quite aware of anticipating. This is the age of internet. We're spreading information like crazy. Everybody hear about it, then they got scared, okay? This is the kind of scare you hear. We got help by Sierra Club, for example. And here's one by American Lung Association, who really, in that sense, if you run the track, my friend Steve Malloy, who you guys have heard, have tracked that maybe, I don't know, $50 million dollars of US EPA pay to ALA, probably pay them to pay this kind of advertisement. And they're trying to link, basically trying to link mercury and arsenic to asthma attack in children. Read carefully those kind of things. It's terrible. I don't even know what this is, crazy. And then, of course, play politics, right? Tell Fred Upton, protect our kids, you are killing children. This kind of scary picture. Well, let's go down to the data. There is an empirical data here, talking about survey of pregnant women about the amount of fish they eat, okay, dark meat or canned tuna, but showing you before the advisory. This is the first advisory that's kind of well known. It's happened about January of 2001, 12 years ago. After post-advisory, you can see people are essentially a little bit scared, so they are aware of that information. If you think that is not updated enough, consider this new paper that just came out 2 weeks ago. Okay? These are also from CDC and FDA kind of people who are actually trying to tell you how much awareness. They concluded that they studied 3 groups of pregnant women. They say that the awareness is really, really very high. But then guess what happened? Because EPA and FDA tell people to eat less than 12 ounces of fish per week. Okay? They're actually consuming less than that now because they're being scared. They are aware of it. So what does that mean? That means the beneficial effects of fish is actually being lost here. Okay? This is not a do-nothing kind of a win-win situation. You're actually causing harm here because people are scared away from eating fish. This is an example of eating fish benefits. Okay? This is a test on children. Here you consider, instead of methylmercury, you consider omega-3 in the fish. Okay? So the consumption level, omega-3, measure in omega-3 sense, and then versus that. Okay? And then for old folks like us, we can have this kind of heart disease. I mean, this is the kind of estimate saying that if you eat fish, you can avoid this kind of US death, that number. I don't trust that number, but I'm telling you it is beneficial. At least it's helping your cardiac health. And this is the kind of list of all the health factors that I think that the omega-3 is actually helping us through fish, because it's very difficult to produce this long-chain fatty acid. And it's through fish. And it has trace amount of methylmercury, mind you, but it also has selenium. It has omega-3. It has all kinds of minerals that we need, actually. So all kinds of things, including cancer. And if you ask yourself, how much Americans are eating now? And I say that we need a whole lot more fish, okay, or fish oil. This is the current intake by US, 0.1 gram per day, okay? And then these are the recommended level. For people with cardiac health disease, they recommend up to 1 to 3 grams per day. Okay? This is the amount we are taking. So we're way below. Compared to other countries, Canada and New Zealand, they are slightly crazy than us, so they kind of don't eat too much, but there's a lot of other places who eat a lot of fish. Of course, don't eat too much like the Eskimos, their level are way too high, and then too much omega-3, you can also have a lot of internal bleeding and all that stuff. So we really certainly need more fish, need to eat more fish. The Americans should be encouraged in that sense. It's a public health issue. So if you think that EPA is being reasonable or extreme, please consider this one point that I think no one even pointed this out yet. Because I guess me, Paul Dreesen, and Juan, we are the few who read all this EPA nonsense. And this is what they actually do. Do you guys know that the scenario they talk about in terms of consumption, they call it hypothetical female subsistence farmer. They really are analyzing situation because they couldn't find the effect. They had to make sure that this is the hypothetical female subsistence consumer that eat a pound of fish every single day for the whole week, and then not only for the whole year, for the 70 years of their lifetime, in order to get poisoned. That's the kind of analysis they're doing. It's just so extreme, out of this world. I don't make this up. I cannot believe they do that when I saw this. You check, it's true. That's what they did. Okay? And then President Eisenhower warned us, this is technological elitism and this kind of scientific abuse, that you have basically NRDC people in a press briefing with the EPA sponsor event, right? Talking about how bad mercury is killing babies, and if you guys denier of this methylmercury in fish being harmed caused by Saddam Hussein, and you guys are not protecting children, and have people like that talking that. I say, what right does he have to stand on this EPA podium? I ain't gonna pay for that. But here's now the final answer. I'm saying that even if one of the things go to near zero, we are being conservative here. Even that the proposition that methylmercury is a neurotoxin is true 100%, and we don't want to challenge that, boom, it's almost zero. So I don't think the EPA chance of being correct and looking good is very nice. It's just wrong. This is why I say that the EPA proposed emission rule can hypothetically save the world, but will ultimately kill people. Only 2 more slides. My personal view. This is really crazy stuff, actually. You cannot believe that things are being published today, These are kind of paper published by people who say, well, we know the danger of mercury emission from polluted, surface soil are understood, they say. But very little. We know so little, so we should spend more money studying this. Influence of ingestion of mercury-contaminated soils. Please learn the word geophagy. I say, is this really a problem of mercury-contaminated soil or poverty? Who on earth want to promote the children eating soy contaminated with mercury? It's a problem of poverty, right? Okay, I stop here. Thank you. I'll be around, of course. You guys know me. Ask me any question later. I'm out of time, I'm sure.